Hello, everybody, and welcome back to Health Economics. I am your lecturer, Liam Puckneys, and we are now on to Lecture 9. This is the last lecture of Week 2 of the course, which is Evidence for Adverse Selection. So, just a reminder, what are the three main predictions from the Akerlof market for lemons and the Rothschild-Stiglitz models? The first is that there's a positive correlation between risk and coverage. So, the more risky you are, the more likely you are to need insurance, the more of it you should buy, right? The more of it you will buy, according to the Akerlof model. The other is that there should be bulk markups, where if you need to buy lots of insurance, the insurance company will charge you more. And then the last prediction of the Akerlof model in particular, but also in the Rothschild-Stiglitz model, is the adverse selection death spiral, right? Where you may end up in a scenario where eventually, right, through repeated rounds of adverse selection, the market completely falls apart. So let's review each of these in greater depth before I go over the empirical evidence for each of these. So first off, we have the positive correlation between risk and coverage. And this comes from the separating equilibrium in the case with imperfect information in the Rothschild-Stiglitz model. So as a brief reminder of that, right, so we have 2 points in this equilibrium, right? The first point, the first contract offered is omega 1, and that's the contract that, omega 1 is the contract that frail people will choose to buy, while omega 2 is a partial insurance contract that robust people will choose to buy, right? So you'll notice here that the robust people do not choose full insurance, right? A reminder, this is the full insurance line in the Rothschild-Stiglitz model. So the robust people do not have full insurance. They do not purchase full insurance, while the frail people do, right? So that means that the more risky you are, right? If you're frail, you're going to purchase more insurance than if you're robust, right? So that's positive correlation between risk and coverage. So the second prediction from the Rothschild-Stiglitz model was bulk markups, where, so before I go into how this plays out, let's define bulk markup and bulk discount. So a bulk discount means that when I buy things, a lot of something, I get a discount on it, right? It means that when I buy, right, you might see this if you go to Costco, right, you're getting a bulk discount when you buy, right, or even when you buy toilet paper or paper towels and you buy, right, the 24 pack as opposed to the 8 pack, right? The 24 pack, each roll in the 24 pack of toilet paper is cheaper than each roll in the 8 pack is, right? Now the 24 pack is still more expensive than the 8 pack, but it's more efficient per unit, right? Where each roll of toilet paper in the 24-pack is cheaper than each roll of toilet paper is in the 8-pack, even if the 24-pack costs more because you're buying more toilet paper. This is also very commonly used in, right, if you buy currency in sort of iPhone games or things like that, right? Pretty frequently, when you buy more currency, when you spend, right, you might get 10 gems or whatever in-game currency you have, right? You might get 10 gems for $1, but if you spend $10, you might get 1,000 gems, right? So if you spend $10 on the game, that's 10 times more efficient than spending $1, right? And so bulk discounts appear a lot in the real world. You see them all the time. You see them in the grocery store. You see them sort of, again, buying everyday items like toilet paper, paper towels are probably where I encounter bulk discounts the most often. And you'll see them in, in those pay-to-win, very sort of, I might go so far as to call them scammy iPhone games. So so what's a bulk markup then? That's the opposite of a bulk discount. It means when I buy a lot of something, I pay more of it per unit, right? So that would be like if I bought a 24 pack of toilet paper and each toilet paper roll was more expensive than each toilet paper roll was in an 8 pack, right? So right, basically the trade-off of the traditional thing when you go to buy toilet paper and you buy a 24 pack of toilet paper is you buy a lot of toilet paper, right? So you risk that, maybe maybe there will be a leak under your sink and then the toilet paper will be ruined. But on the other hand, it's cheaper per cost per toilet. You get a cheaper cost per roll. And a bulk markup is the opposite of that, where you buy a 24 pack of toilet paper, and it's more than 24 times the price of a single toilet paper roll. And so bulk markups are weird, right? We don't think of those as they don't occur very often in our everyday lives, right? The exception might be sometimes, again, if we're going to go back to those iPhone gotcha video games, right? Where sometimes if you pay attention to the pricing of each plan, you'll notice that the most efficient plan is actually the second most efficient plan. The most expensive plan is the second most efficient plan, and the most efficient plan is the one right below it, right? So you might, if you spend $50, right, maybe you get 500 gems, but if you spend $100, you only get 900 gems, right? So it's actually better to buy two $50 plans than one $100 plan. And the reason they're doing that, by the way, is to trick you into thinking you've gamed the system. They're actually gaming you. And don't fall for it. Well, at least, don't let that influence your decision. It may be that you may maximize your utility by buying two $50 plans. Who am I to judge? Well, I'm actually a pretty judgmental person, so I will be judging you if you spend $100 on a gotcha game. If it's a bad one, actually, I've spent. Now that I'm thinking about it, I actually have spent several $100s on games like that, but they were classy. Anyway, but bulk markups rarely occur in the real world, with the exception of occurring in insurance markets. It actually is pretty common to see bulk markups in insurance markets. So an example of this would be when you go to purchase health insurance, right? So the Rothschild-Stiglitz model, right, predicts that, again, right, going back to this thing here, right, that the frail people are going to pay a higher cost per coverage compared to for each unit of coverage compared to the robust people. And we actually do see that in the real world, right? So if you compare like a PPO plan to an HMO plan, right, where a PPO plan covers more and is allows you to get more coverage, like PPO plans are less efficient than HMO plans, right? And that's a bulk markup, right? When the more comprehensive insurance coverage is less efficient per unit per dollar spent on healthcare than the cheaper plan is, which is often the case. That's an example of a bulk markup. So bulk markups do exist in healthcare plans, and if you want evidence of that, get a job and see what the healthcare plans are, right? There will probably be evidence of a bulk markup. Probably, right? You're not guaranteed to get it right. Health insurance plans are weird, and there's lots of government intervention, and employers will use health insurance plans to try to force people to pool, right? They'll try to force healthy people to pool with sick people, or incentivize healthy people to pool with sick people. So health insurance in practice is weird, but we do often see bulk markups in the real world. And the evidence of that is, get a job, see what insurance plans they offer you. And this is exactly what the Rothschild-Stiglitz model predicts. So that's a win for the Rothschild-Stiglitz model. And then lastly, we have the adverse selection death spiral, right, which occurs in both the Rothschild's model and the Rothschild-Stiglitz model and in the Akerlof model, but it's maybe a little easier to think about in the Akerlof model, right? So this is these, I guess, we're going to read these pictures from left to right instead of right to left, or pretend you're reading like a Japanese comic book or something. So if in the first round, if in the first year you offer insurance at $10,000, these customers will not buy insurance, right? The customers whose expected healthcare costs are less than $10,000, they don't buy insurance. But in the next period, in that same period, the customers who do buy insurance are the people whose expected healthcare costs are more than $10,000, right? So the expected value of the average cost of somebody who's buying insurance is $15,000 in the first year. So then you say, okay, so next year you say, okay, so last year the average amount I spent on a healthcare plan was $15,000. So I'm going to raise my insurance premium from $10,000 to $15,000. Well, what happens then? Well, these people were already not buying. They stay not buying. These people drop out of the market, right? Because if my average expenses were $14,000, if I expect my expenses to be $14,000, but the price is $15,000, I might not buy that plan, and I won't buy that plan if I'm risk neutral, if I'm not risk averse. So these people, right? These people are now these people, and they drop out, and then the only people left are people with whose expected healthcare costs are greater than $15,000. And so, then you reset, and this becomes your new price, and then this becomes your new price, and that becomes your new price, and eventually the market falls apart, right? So the adverse selection death spiral is a very worrying thing. But we need evidence of it occurring in practice to say, this is a thing that actually happens, right? It's the economic models, right? Both the Rothschild-Stiglitz and the Akerlof model for lemons indicate, hey, this is something to be worried about. But none of our economic theories matter if they don't pan out in the real world. So what sort of evidence is there of an adverse selection death spiral, right? And we actually have a few very good cases of that. So first, let's start for evidence of adverse selection generally, right? So what is the whole reason adverse selection happens? Adverse selection happens because in the theory, the whole theory why it occurs is because frail people, right? In the Rothschild-Stiglitz model, the whole reason adverse selection occurs is because frail people know they're frail, and insurance companies don't know they're frail, right? So more broadly, the adverse selection happens only when individuals have better information on their risk than their prospective insurers do. And right out the bat, we're going to go back to the RAND health insurance experiment, right? The old stalwart, the RAND health insurance experiment, right? That's where they randomly assigned insurance plans to people back in the 80s. And what they found from that is that individuals can predict their healthcare costs for the year to a decent degree of accuracy. And very importantly, they can better predict their insurance costs than a health insurance could, right? They can better predict their healthcare costs than a health insurance company could, right? So that means like, oh, okay, so this is evidence, right? That we have evidence from RAND that that individuals do in fact have better information on their on their risk than insurance companies do. And very importantly, families with higher predicted costs were more likely to say they wanted to buy additional insurance, right? So if you remember, the RAND healthcare experiment sort of capped people at a certain amount, right? So you either all your expenses were paid, or 25% of your expenses were paid, or 50% of your expenses were paid. Sorry. You only had to pay either all your expenses were paid, 75% of your expenses were paid, 50% of your expenses were paid, or only 5% of your expenses were paid. And people who had higher healthcare costs said they wanted to buy more insurance. If they were able to, said if they were given the option to, I would like to buy more insurance, right? And so that's very that's evidence again of adverse selection, of that adverse selection may be a problem here, where the sicker people are saying, hey, the frailer participants in the RAND experiment were saying, hey, I think I would want better insurance. And by the way, we can tell that they do know their own risk better than an insurance company would. So outside of RAND, there are many studies that find positive risk coverage correlation in the U.S. healthcare market, right? So here's a huge list of them. There's a bunch of them. We're going to focus here on Finkelstein, Hendren, and Shepard from 2019, in part because it's it's a recent study, right? It's from 2019, And so, right, that's much more recent than the other studies in this list, right? 7 years younger than the next oldest study on the list. And because we're going to come back to this study later, next week when we discuss sort of implicit insurance, Medicaid, and why don't more people buy health insurance in the U.S. So I'm going to introduce it to you now. You'll see it again a few times through this course. So what did Finkelstein, Hendren, and Shepard study, right? So they looked at the Massachusetts Health Insurance Exchange for low-income individuals, which is called ComCare, right? So I don't know how many of you really remember the Obama-Romney election from 2012, but one of the things that Mitt Romney did when he was Massachusetts governor was really promote a public health insurance program, somewhat similar to Obamacare, and that was, depending on who you ask, it was either a selling point or a liability for him when he ran against Obama, because whether Obamacare was a very contentious public policy issue, what the government should do in with health insurance in the health insurance market was very contentious, right? Obamacare had been passed a few years earlier, and Mitt Romney was a moderate Republican governor who had implemented a health insurance exchange similar to Obamacare in Massachusetts years before Obamacare came, right? So this is looking at the Massachusetts health exchange insurance for low-income individuals, right? Which again is called ComCare. Now, how did ComCare work, right? It offered really heavy subsidies to non-elderly adults below 300% of the federal poverty line, right? You might say, what about the elderly adults? Don't they need help? Well, in the U.S., if you're elderly, you're eligible for Medicare, so you already had free health insurance. So the sort of the gap in coverage, and high-income people already have health insurance, so the gap in coverage is mostly the low-income people who are non-elderly and adults, right? And so 300% of below the federal poverty line, that's a fair number of people. And the way this would work is the government would subsidize your insurance plan. And they use these subsidies to estimate demand for care plans. And very importantly, one feature of these subsidies is there were income thresholds at which the subsidy suddenly dropped. So, right, so this is, you can see here, this is the premiums for the cheapest plan from 2009 to 2013. And you can see if you were at below 150% of the federal poverty line, your health insurance was free, right? But all of a sudden, if you were at 150 to 200% of the federal poverty line, right, your premiums were $40 a month, right? And then if you were at from 200 to 250%, your premiums were $75 a month, $78 a month, right? And if you were at 200, if your income was 250 to 300% of the federal poverty line, you had to pay like $117 a month, right? And so you have these like sudden spikes, right, here, and here, in how much people were paying for care. Now, this is great. This is what, if you've taken econometrics, right, you may have seen this before. This is called a regression discontinuity, right, where, or economists can analyze this using something called a regression discontinuity. And the basic idea is income is continuous, right? Income's a continuous variable. And so, right, there's not, the idea is that there's not really any significant difference between somebody earning 150% of the poverty line and somebody earning 149% of the poverty line. Other than that, the only difference between those two people is the price that they have to pay for health insurance based on this public policy. And so this is really good news for economists, because we can say, okay, someone who's at 149% of the federal poverty line is probably statistically identical on average to somebody earning 150% of the federal poverty line. So any difference in coverage we can see between these two groups is probably driven by this difference in the subsidy we're seeing. And so this was a very clever study that used this to get an idea of how much do people value insurance, which we'll get to later. And it also found evidence for adverse selection, right? So another way to think about this is, right, how big is the public subsidy for each of these income thresholds, right? So if you're between 135 and 150, the public subsidy for the cheapest plan, which is that's Celtic Care, right? That's the plan down here, is 100%, right? They're paying everything, right? And then it's still a generous subsidy, but the subsidy drops if you're between 100 and 150 and 200% of the poverty line. It drops again if you go from 200, like if you go from 199 to 200, the subsidy you're getting plummets, right? Well, it drops, going up by about $40. I don't know if you would say that's plummeting. And then again, if you go from 259 to 250% of the federal poverty line, the amount of subsidy you're receiving drops again, right? So sort of the gap between the green line here and the dotted green line down here and the solid green line there is how much the government was subsidizing insurance plans for people with the income on the x-axis. So what do they find? Well, first of all, they do see that right when your coverage increases, right, we see a big drop in the number of people buying the insurance, right? So, so when your coverage is free, right, you have lots of people, right, lots of people buying the insurance, right? Income drops, the premium goes up, right at these lines here. These are the lines at which your premium rose, right? And we can see right around those lines big breaks in how many people are buying health insurance, right? Especially when you go from free to 40, right? That's the biggest, but we also see that here, right? So you can see there's a 26% drop at the first threshold, right? When you go from 149% of the federal poverty line to 150% of the federal poverty line, right? The percentage of people buying insurance drops by 26%. When you go from 199 to 200% of the federal poverty line, the percent of people buying insurance drops by 27%, and by 25% when you go from the 249% of the federal poverty line to 250%, right? Those are sudden drops, right? So we can see there's a gradual drop in the likelihood of getting health insurance as you get richer through this program, but we see big drops when there's an increase in premium price. So what's the evidence for adverse selection out of this? This is this graph here. Now, this graph is a little tricky to read, so I'm going to point out what the evidence for adverse selection is here. So these are average insurer costs by income, right? This is how much, for a given income threshold, people were paying, insurance companies were paying, right? And you'll notice around the times the income, the premium plans go up, less so here. But definitely for right here and right here, right, when the price of your healthcare goes up, the insurer costs spiked too, right? So what does that mean? It means the people who drop out, right, are people with low insurance costs, right? Why are the insurance costs down here so low? It's because healthcare costs are free. Everyone's getting free healthcare. So basically everybody's pooling, right? So the risky people are pooling with the frail people. Sorry, the frail people are pooling with the robust people because healthcare is free. So it doesn't matter, like it's free whether you're robust or frail. So all the robust people are fine pooling with the frail people. And so the right down here, there's pooling going on. There's less pooling going on up here, right? When you increase the cost, who drops out? It's healthier people, right? The people who decide not to continue on the plan are people who are less likely to get sick, right? The robust people are more likely to drop out of the coverage pool. And so this is I think this is a very cool graph. I think this is one of the clearest examples of adverse selection, right? This is one of the cleanest I think this actually is the single cleanest example of adverse selection I have seen in empirical analysis. We'll go into why it can be difficult to find evidence of adverse selection in some cases later on. But we can see here, we see very strong evidence of adverse selection, where when the price of the plan drops, when the price of the plan goes up, the healthy people drop out, and average insurer costs go up. So next up, let's look at evidence of an adverse selection death spiral. Now it's worth noting, right, neither the Akerlof model nor the Rothschild-Stiglitz model suggest that the adverse selection death spiral is mandatory, right? Neither of them says this is guaranteed to happen. What they say is this can happen. So unlike the correlation between risk and coverage, to find evidence of an adverse selection death spiral, right? We just need to find examples of this, right? In order to say the model's predictions hold in reality. We don't need to say, right? If you want to say we don't need to say it holds in every case, right? If you want to say that the Rothschild-Stiglitz model is always correct, you will need to find some examples of adverse selection death spirals, as opposed to correlation between risk and income. You would need to find those two things are always correct, because are always that you would need to, if you want to say that the Rothschild-Stiglitz model is always correct in all circumstances, it always predicts that more risky people will purchase more coverage. And so it must be that in every single case you look at, more risky people are buying more coverage. It does not always, neither the Rothschild-Stiglitz model nor the Akerlof market for lemons predict that insurance markets will always collapse. You just need to find some examples of the adverse selection death spiral to say, okay, it yields accurate predictions on the adverse selection death spiral, again, because both the Rothschild-Stiglitz model and the Akerlof model only predict the adverse selection death spiral will come sometimes. Now, the geniuses over at Harvard have provided us with an excellent example of an adverse selection death spiral, and we're very thankful to them for it. We are thankful to them. Obviously, this was not good for Harvard. So let's look at their health insurance, right? So Harvard, as an employer, offers its employees health insurance, right? University of Maryland does this too, right? I get health insurance through the University of Maryland. I'm effectively an employee of the University of Maryland. So Harvard offered two plans. There was a PPO, which that's better coverage, right? That's more comprehensive coverage. It covers more things, and an HMO, which covers fewer things, right? And in 1994, about 18% of Harvard employees were enrolled in the HMO. They were paying a premium of $361 for it. And the HMO, 82% of employees were enrolled in the HMO, and they paid a 0% premium for it, right? And Harvard was trying to make their budget, their budget balance, and they didn't want to touch their precious endowment. And so they decided, okay, we're going to raise the price of the PPO because we're losing money on it, right? So what happened, right? Well, some people left the PPO and moved to the HMO, right? So these are the PPO leavers, right? These people, they moved, right? These people here moved from the PPO to the HMO, right? So they switch plans. Now you'll notice that these people are healthier on average, right? So older people tend to be less healthy. So 31% of people under the age of 40 left the plan. 13% of people over the age of 60 left the plan, and they on average had 6% less spending than the people who stayed, right? Now the PPO stayers were much more likely to be old, they were less likely to be young, and they also spent more on healthcare, right? And so Harvard said, now we're still losing money on the PPO. What do we do? And they said, okay. We'll raise the premium, right? So they raised the premium to $700 in 1995. So in 1996, they said, we're losing money on the PPO. What do? I know. Let's raise our costs again. So they raised the cost of the PPO to $1,400. And they should have consulted an economist before they did this, because what happened is, right, so more people in the PPO left, right? So these people, right, they went from the PPO to the HMO, right? These people are now here, right, which is now in the HMO box, right? And so they raised the price. More people dropped out of the PPO to get to the cheaper plan. And by 1996, right, only 9% of people were enrolled in the PPO. 91% of people were enrolled in the HMO. And the people who left in the second round of adverse selection from 1995 to 1996 had 9% more spending than the people who left, right? And they were even more likely than before to be old, right? This is a very clean example of a adverse selection death spiral. And after 1996, Harvard said we're losing money on this, and they just stopped offering the PPO. So this is a very clear example of an adverse selection death spiral occurring in the real world.